Hello everyone, hi. This is the supply chain management and logistics. In the last class, I spent quite a time to talk about how to realize the supply chain coordination in managing the cycle inventory. Today, let me focus about the how to manage the cycle inventory in entire supply chain system. So let me get into the PowerPoint slide. Okay, as you know, that most the supply chain system have more than one the stages, so-called multiple echelon. So under this situation, the still goal is how to minimize the cycle inventory in the entire system. The thing is, in order to manage the cycle inventory in the entire system, what we have to consider is not only about the order size, we have to focus on the timing of order. Okay. So for example, let's say, let me get to the notes. So here, for example, let's say that just a usual, just the simple supply chain structure, starting from the manufacturer, and also we have the wholesaler, and we have a retailer. Just talking about that the simple three-stage the supply chain system, for example. Okay, then each these manufacturer is supposed to make the order. So here I'm just trying to draw the timeline in the continuum. Okay, so without any coordination here, okay, that the talking about each these the supply chain member the determines the its ordering time. That is, let's say manufacturer order this time and this time and this time and this time. Okay. Probably wholesaler also determine his ordering time in on his own, such as like this one and this one is probably more frequently in a smaller size. And also in a retailer determine his own the ordering time like this, probably more frequently than smaller size. This way. Okay. So this is a very conventional way that in any supply chain system that each supply chain member decided their ordering time to order. But the thing is, problem is, it's not only about the order size, it's about ordering time. Is because of this mismatch between the ordering time, in terms of ordering time between the different stages in the supply chain system, okay, we supposed to have much of the cycle inventory. Okay, so the idea to reduce this unnecessary cycle inventory is very simple. What is that? Yeah, you try to match them. Okay, so probably better idea is instead of this the different way, this individually they decided their own ordering time. Somehow we try to match the ordering time this way. But still we have to concern about that is the probably manufacturer doesn't have to order so much frequently like a wholesaler, probably less frequently. So let's say this way. But still, the wholesaler may decide to order in a not that exactly match the timing, the match with the manufacturer ordering time. Okay, that instead probably he order this way. So he matched the one in a second time. He wholesaler order manufacturer's order, so that way he can match at least this way, and also the wholesaler just continue wholesaler order this way So that way, that the when wholesaler orders second time, the exact that time that the manufacturers order, that way we can still try to synchronize this ordering time. And for the retailer, the same idea. Probably retailer need to order more frequently than the wholesaler, of course, more than the manufacturer, more frequently than the manufacturer. But still, we can think about this way. So here's the idea is again, when retailer orders second time, the wholesaler order that way match the ordering time were between the wholesaler and the retailer. Okay. So in this way, probably we are not able to totally remove the cycle inventory in this system, but still we can reduce a lot of cycle inventory because we can synchronize the ordering time in the different stages of supply chain system. Okay, so let me get back to the slide. That is here we're saying that is the way we can synchronize this lot size, the ordering time in a different stage in the supply chain system is so-called nested and stationary interval. Means once you have this ordering time in each stages, then you're not supposed to change at all. Okay, that means it's a nested and a stationary interval. Okay, it's fixed over the time. In once you have it, that certain the time interval for the orderings, then you never change. Okay. And also another idea to reduce the cycle inventory in the entire supply chain system is a so-called cross-docking system. Okay. So what is a cross-docking system? It's actually first introduced by the Walmart. That is, let me get back to my notes. That is, under this, the cross-dock system is there's a one place is that so-called cross-dock. Okay, thing is, you can easily imagine that is that there are many different, probably more than 1,000 different the Walmart store in the United States only. Okay, and also each Walmart store handle the more than 1,000 different product item. Okay, so here is the saying is just imagine you have many of these the Walmart store in the certain places. Walmart store number 1 and number 2 and the number 3 and the number 4. Okay, just to have an example. And then also to supply each this Walmart store, okay, that there will be many different the distributor or manufacturer here. Such as this is a supplier for the each Walmart store, supplier 1, number 1, number 2, I'm sorry, is then number 2, number 3, and number 4, number 5. Okay. So according to this, okay, each supplier is supposed to provide and deliver their product to each Walmart store. Okay. But here's the saying is if this each supplier, okay, to deliver their product to each store, okay, directly, so point to point, okay, this way, then it's supposed to be very complicated, okay, and then time consuming, okay. So this is not so efficient way to deliver the product, okay, because of inefficiency. So you might have a lot of the inventory, especially the cycle inventory, okay, because that much it take the time and that much is going to cost a lot, okay. So the better idea here is instead of using this point-to-point delivery system, the Walmart introduce a so-called cross-docking system. So in between this the supplier and the Walmart store place, okay, the Walmart have a cross-dock. In a cross-dock it's a very different just conventional inventory warehouse. Okay, so in a cross-dock place, you're not supposed to store any product. It's just what happened inside of cross-dock is just a sorting and distribution. Okay, so before supplier send to the any product to the Walmart store, any product go to the before go to the Walmart store is supposed to be passing through the cross dock first. Okay, so no matter what that is, no matter who that supplier is, he's supposed they supposed to deliver the product in a cross dock first. Okay, and then what happened inside of cross dock is once this cross dock receives there are many different kind of product and it's going to be assorted. Okay, those are many product is assorted depends on the product item and also that where it to go. Okay, so which Walmart store is closed. Okay, so then it just without any stopping point, it go to the Walmart store with other product supposed to go to that each store. Okay, so that way it have a more efficient, okay, and then cost saving system. Okay, also because of that, okay, it's already sorted inside of a cross-dock. Okay, so that way the and also is time is getting shorter to deliver the products. So that way that the in this system, especially in each Walmart store doesn't have to have a lot of the cycle inventory. So this is a very good idea to have a cross stock to reduce the cycle inventory and also make a efficient delivery. Okay. So let me go back to the slide here. Okay. So that is the idea that how we can manage the cycle inventory to try to minimize cycle inventory amount, okay, in the multiple stages supply chain system. Okay. So now it's time to conclude that all about the managing the cycle inventory. So what we learned from the previous classes is what we better aggregated, okay, or the fixed cost across the multiple product and the supply point and delivery points, okay, just like a cross-docking system, okay. So, and also, okay, you better make a quantity discount consistent with the manufacturing and logistic operations, okay. We already saw this example how to use that volume-based quantity discount and two-part tariff to bring the supply chain coordination. Also, if the traditional trade promotion is really necessary, it's good to have a so-called everyday low prices and the based on the discount based on the sell-through rather than the sell-in. That way we can realize supply chain coordination without that increasing cycle inventory. So that's all about the how to manage the cycle inventory in this class. Okay. So now let's move to the story that is. Now it's time to talk about another kind of inventories, that is the safety stock. This is chapter 12, then in the textbook, the math is the safety stock. So why we have a safety stock? Because we are afraid if the demand is greater than the amount of a product we expect. So we are not able to fulfill the customer's order. Okay. So the reason why we have a safety stock is because of the uncertainty of demand and supply, as I explained before. The thing is, the average cycle inventory so far, we just include only the cycle inventory. But in fact, the average inventory that is combined with that inventory, cycle inventory, and the safety stock. But deciding the proper amount of safety stock is not an easy job to do at all. Okay, why? Because in order to have a higher level product availability and customer services, you have no choice other than to just increase the safety stock. So here's a product availability means that is how well we can fulfill the customer's order. Okay? For example, let's say your customer want to buy 100 unit of product from you, but if you have only the 90 unit of products, then your product availability is just a 90%. Okay? 10% you are not able to provide a service to your customer. Okay? So because of that, okay, so because if you wanted to have a higher the product availability, you should have enough amount of inventory. That's it. And also another thing is, in order to increase the safety stock inventory to have a higher level product availability, then suddenly you should maintain a higher amount of the average inventory in your warehouse, and that much you have to pay a lot of the inventory holding costs. Especially having a lot of inventory in high-tech industry is very dangerous because normally the product in high-tech industry have a very short product life cycle. Okay? So the good example is like a personal computer. Okay? That the value of a personal computer is decreasing very fast as time goes on. So that much the holding the much of the PC in as a inventory in a warehouse is could be you could lose a lot of money as time goes on. Okay, so that's why is you have a difficulty in determining that the proper amount of safety stock. You have to consider the two things at the same time. That is the product availability and also inventory holding cost. So here's two important questions, okay, regarding the how to manage the safety stock. The first one is, what's the proper amount of safety stock you have to hold in your warehouse? Okay, that's the first question you have to answer. The second question is, how can we improve the product availability, but at the same time to reduce the safety stock? As I said, there's a certain trade-off between the product availability and the safety stock. Okay, so that's why this especially this second question is not easy to answer. Okay, but anyhow, let's try to find out the proper answer to these two questions. So in order to getting answer to those two questions, okay, we have to understand all these things. The first, how to measure the demand uncertainty and how to measure the product availability and how can we set the replenishment policies and etc. Okay. So first, that is that normally proper level of safety stock is determined by the two factors. First one is supply or demand uncertainty, and second one is what's the desirable level of product availability. Okay, so we are not able to get rid of the uncertainty at all. Okay, we probably by make some effort and spend the time and the money. Okay, we are able to reduce uncertainty, but still we are not able to remove uncertainty at all. Okay, so good example is like what is a demand forecasting. How can you possibly forecast your demand correctly 100%? That's impossible. Okay, so somehow we allow that the uncertainty in demand and also supply. And also regarding the product availability, that is, if you have a 100% product availability, it's a good idea. Okay, it's could probably the best. But on the other hand, having the higher product availability is not a free. You have to pay a lot of money for that. Why? Because as I said before, in order to have a higher product availability, you should increase the the inventory in your warehouse. That much is going to cost you a lot, especially the inventory holding cost. Okay. So probably the better idea is instead of a 100% product availability to provide 100% the good services to your customer. Probably in order to save the cost, I better have the less than 100%, but not so the smaller, like what, 50%. Okay. But anyhow, this when you decided the proper amount of safety stock, we have to consider these two things at the same time: the uncertainty in demand and supply, and also the product availability. But the thing is, again, the reason why it's so much difficult to have a proper amount of safety stock is because high level uncertainty require high level of product safety stock. And given in that, the fixed amount of fixed level of product availability. And also, in order to have the higher level of product availability, you need to store a lot of safety stock in your warehouse. Now continue. First of all, let's find out how we can measure the demand uncertainty. Normally, the demand has two components. First one is a systematic component, and second one is a random component. I can say is mostly that uncertainty coming from this random component. Okay? Random component also usually estimated by this so-called standard deviation of demand. Okay, the standard deviation, you might heard about this before, is from the one of the statistics course. So in fact, when we talk about the safety stock, we need to apply the statistics. Okay, especially the probability distribution. Okay, so let me get that point in the later on. Okay. So here, that is I'm going to use some of the formula to indicate it that is the about the demand, nature of demand under the uncertainty. That is, for that, I need to specify the notation. That is, let's say capital D is just average demand during the certain time period. But here we already saw the capital D before, right? When we talk about the cycle inventory. But that the capital D, the demand at the cycle inventory, and this demand at the safety stock is quite different. Okay, why? Because when we talk about the demand in the cycle inventory, the demand is fixed and there's no uncertainty at all. Okay, so once its demand is 100 in a year, then it's always 100. Okay. So this is one of the assumptions of a EOQ. Okay. But on the other hand, when we talk about safety stock, we allow the uncertainty. So that's why here's D is just we are not able to specify the demand as a fixed number. We are only able to describe any kind of demand in terms of average and standard deviation. Okay, why? Because demand is uncertain. Okay, so you should understand difference between the actual demand, the demand, fixed demand, and average demand. Even though average demand is 100, that doesn't mean that your demand is always 100. Okay, average demand is just you're going to have that much of a demand on average. Okay, so even if the average demand is 100, that doesn't mean that your demand is always 100. Either it's a 90 or 200 or whatever, but on average it's just 100. So don't misunderstand. Okay, that is, this is a same. Okay, the demand from the cycle inventory, this is a very different meaning. Okay, and also especially because in order to describe the uncertainty of demand, we use so-called standard deviation. Okay, so sigma D here, so-called standard deviation of demand during the certain time period. Okay, also L here is the lead time. We already learned about this lead time. The lead time is time difference between when we place order, and when we receive that order the product. Okay. So let me get back to my notes. It is. So with these notations, what I wanted to describe is this one. That is, this is just the one case is in a continuous. Let me make it bigger. The review system. The continuous review system is one of the inventory management system. But let me explain about this, getting details about this continuous review system later on, okay? But anyhow, let's say I'm under the situation of continuous review system. I'm using this system to manage my inventory. Then the way I describe the expected demand, the average demand, during certain time period, such as a lead time, and this is a way we can calculate the average demand during the daytime. That is a D, the notation I already explained, and multiply by L. Okay. And then what about safety stock amount? Normally, the way you decided safety stock amount under the continuous review system is the so-called reorder point. This is so-called reorder point. Even though you not understand this one, but you don't have to worry about, because I will get in the details about this is reorder point later on, okay? And then again, get back to this formula. The safety stock amount is just a reorder point minus the average demand during the lead time, okay? So that way we can decide it, the proper amount of safety stock under the continuous review system. Even though you're not able to understand this, don't worry about it, because I just giving you this example to get to how to get the proper amount of safety stock under the certain system, okay? So here, continue. Let's get to get back to the PowerPoint slide, okay? So, and, sorry. The next page is, and regarding the measuring the product availability, okay, product availability again is a company's ability to fulfill the customer's order out of available inventory. So stock out is kind of the opposite meaning, that is, customer not able to receive the product, okay, from the current available inventory. Okay? But there's many ways to describe the product availability, okay, that is, that among them, these are the three most popular way to describe the product availability. The first one is the product fill rate. The second one is order fill rate. The last one is cycle service level. Okay, the product fill rate is kind of fraction of demand can be satisfied from the product in the inventory. Okay, and the order fill rate is the fraction of order instead of demand that are fulfilled from the available inventory. So both the product fill rate and number of fill rate is like a percentage of the products. Okay? But on the other hand, the last one, cycle service level, is quite different from the previous two ones. Okay, that is, this is a fraction of replenishment cycle that end with all the customer demand met. Okay, so what is a cycle? Probably you remember, that is, I already mentioned about the cycle when I talk about the EOQ. It's like one cycle, okay? When we have a cycle, okay, no matter what that is, if you have a cycle in inventory management, that is a time period, okay? So you remember, that is, when I talk about cycle in the EOQ, that is cycle indicating that time between orders, okay? So once you order enter, what's the time duration you have to wait until the next order? That is a cycle, okay? So here is that the cycle service level indicating fraction of a time can matter the fraction of a product. Okay, so this is indicating that fraction of a time that you can you can provide a service, full service to your customer, okay, by using the product in your warehouse. Okay, so during this time particular time period, you are able to that the fulfill all the orders customers order. Okay, that is the meaning of the cycle service level. So that's a quite different from the product fill rate or the order fill rate. Okay. And let me get to the memo here, my notes here. Okay, that is. So here I'm trying to show how to measure the safety stock in a given certain replenishment policy. Okay. Oh, talking about replenishment policy, that is. Let's get to the PowerPoint slide again. Okay. And I can say there's 100 different kind of the inventory system out there. Basically, I can say the company may use their unique, the inventory system. Okay. But on the other hand, we may classify many different inventory system into these two things. Okay. The first one is a so-called continuous review system. The second one is a so-called periodic review system. So what's the difference between the continuous review system and periodic review system? That is, the difference between them is based on the what? How we monitor the inventory level over the time. Okay. In a continuous review system, you can easily understand it's a continuous. That means what? You keep watching out your inventory level continuously as time goes on. Okay, you never lose your sight on your inventory. You always keep looking at the inventory level, and as time goes on, so you always know how many inventory you have in your warehouse. Okay, that is a continuous review system. But on the other hand, there's another one that is a periodic review system. So periodic review system is what? You not keep watching your inventory as time goes on, okay? Just your time to time, you drop by your warehouse, and then at only that time you check out your inventory and figure out how many inventory you have. Okay? That is a period review system. So question is why we have to classify the inventory system in terms of how we watch over the inventory as time goes on, because depends on whether you use the continuous review system or the periodic review system, the way you decided important decision, where you make the important decision regarding the replenishment policy could be very different. Okay? So basically, let me get back to the notes. That is, there are two most important the decision in regarding the any kind of inventory system are the what? First, the how much to order. That's the first one. Okay. The second decision is most important decision in inventory management is when to order. So basically order size and also the order time are the most important decision you have to make regarding the inventory management. Okay, so reason why that is because these two decisions are important because depends on how much to order and when to order. The amount of inventory you hold as time goes on could be very different. Okay. So go back to the continuous review system and the period review system. The reason why that we classify any inventory system in terms of how to watch over the inventory. So classify either the continuous repeat system or the periodic repeat system is depends on whether you use periodic repeat system or continuous repeat system. The way you decided when to order and how much to order could be very different. Okay. So let me get back to this one. Okay, that is about how we can decide on how much to order and when to order under the continuous repeat system and the periodic repeat system. Okay, later on. Okay. So here it is. I'm trying to describe the how to evaluating the safety stock, the given a certain the differentiation policy. Okay. So here's that is that let's say this is the D is again average demand during a certain time period. Sorry. So certain time period and the lead time is L. Then under the continuous repeat system, expected average demand. Expected means just average. Okay. Oops. Sorry. Average demand during the lead time is D multiplied by L. Okay. And then again, safety stock is just a real point minus D multiplied by L. Okay. So by using this formula, we already have this. Okay. Let me have an example. This is an example from the textbook. That is example 12-1, the page 331. The given information is the demand in this the average demand of this company is 2,500 per week. Okay, so weekly average demand is 2,500, and sigma d, the standard deviation of demand of weekly demand, is the 500. The lead time is 2 weeks. That means once you place order, you can receive the ordered product the 2 weeks later. Okay, and then real point is 6,000, and then Q, that is order quantity, that is 10,000. So here's that, just like a EOQ. Okay, you try to order the exactly same amount, 10,000 unit every time you order. Okay, and then what happened here is the safety stock amount is just according to the formula I already gave you, the real point minus the D multiplied by average demand during the week, during the lead time, that is 6,000 minus 2,500, okay, and multiplied by 2. That is 1,000. That's the amount of safety stock you're supposed to have in your system. Okay. And then the cycle inventory, because we order exactly same amount over the time. Okay. So that's why this is just a way we can calculate the average cycle inventory in a EOQ. What is that? Just a Q divided by 2. So 10,000 divided by 2 give me 5,000. So after all, how much the inventory you have at this time is not only about cycle inventory, you have to add the safety stock. So average inventory total is the cycle inventory plus the safety stock. It's just 5,000 plus 1,000. That is a 6,000. Continue. So once you have this average inventory, and then you can calculate the average flow time. So what is the average flow time? How long each inventory stay at the warehouse is on average. Okay. So in fact, the average flow time, the way we calculate it is just the average inventory divided by the throughput. So what is throughput? Throughput is that this is indicating total amount of product that passed down to the entire supply chain system. So here's that we're saying is just the entire demand. Okay, because we are not able to know that exact the demand here, we're just using the average. Okay, so this is actually the concept is we are trying to calculate that the average time period that is each inventory stayed at a warehouse. So let's say this is a warehouse, then probably you'll have to consider the input and output. So what is the input here? It's just the demand. I'm sorry, it's just the, the inventory, how much inventory you have, okay? And then what about output? So it's the demand, okay? It's just because of demand is you're going to take out this inventory from your warehouse, okay? So this is just simply the input over the average flow time is just input over the output, okay? So this we already have 6,000, the average, the inventory, and average the demand. Okay. So in the end, it's just a 2.4 weeks. Why this is a weekly basis. Okay. So I can say that is under this system, the continuous review system, we supposed to hold a safety stock amount of 1,000 units. And cycle inventory on average is 5,000. So total average inventory level is the 6,000. Okay. And then each inventory stayed at a warehouse on average 2.4 weeks. Okay. And then next, that is before I move to the next ones, especially this is the next about how to evaluate cycle service level. Okay, cycle service level is one of the way to indicate the product availability. But the thing is, in order to understand that is you should have some of the basic, the statistics, okay, especially in about the probability distribution. Okay, so from now on, let me spend quite a time to talk about the basics of statistics. I'm not going to teach everything about the statistics. I'm going to just teach the portion, small portion of statistics you need to have. You need to understand to learn about this safety, managing the safety stock. Okay, so here let's say let me spend some time talking about some small portion of statistics. Okay, especially probability. So normally the way we provide the probability, okay, that is, let's say this is one of the function. So here's x is the event. So let's say fx is a function of the probability that indicating what's the chance to have this event happens. Okay? So especially this is a so-called the density function. So in fact, there's another way we can describe a probability. It's like a cumulative, cumulative probability. That is that this is different, okay? But let me just focus on this. I don't want to make you confused, okay? So probably instead of this function, you may just simply indicate like a px, okay? So normal way to describe what's the probability that x events happen, okay? But talking about a probability, there are many different kind of probability out there. Especially, normally we classify the many different probability into two classes. The first one is so-called discrete, the probability. The second one is so-called continuous probability. Okay. So what's the difference between the continuous probability and the discrete probability? The discrete probability is event itself is discrete. It can have just the individual independent discrete, okay? So it's just make it the discrete events, okay? So under the discrete probability, you describe the way you describe the probability is what? Just this way. This is like x. Let's say this is x, okay? But on the other hand, the continuous probability, you are not able to describe the probability this way, okay? Under the continuous, this is a continuous value. There's no discrete here, okay? Just like a discrete is, if you toss the dice, okay, what kind of event you might have? Let's say here's the event is a number, once you toss the dice on the floor, the event I'm interested in is a number that you can see on the top of a dice. That is a what? Just a 1, 2, 3, 4, 5, 6. Okay, that is a discrete. Okay. But on the other hand, the continuous probability, you don't have this a discrete case for event. Okay, you have only way to describe a certain probability is just the interval. Okay, so we don't have this kind of way to describe the continuous probability. Instead, the only way you can describe the probability under the continuous probability is what? With using the interval between A and B. So this is a something. Okay. So this is the way you describe the continuous probability. Okay. So talking about the continuous probability and discrete probability, okay? So you may already learn about the different kind of a discrete probability distribution and continuous probability distribution. The example of a discrete probability distribution is so-called Bernoulli, that famous, and binomial, and Poisson, and geometric. Those are the discrete probability, okay? And what about continuous probability? That is uniform and gamma and a beta, F, distribution and student t distribution and chi-square. Those are the continuous probability distribution. Okay, but probably the most popular, the continuous probability, probably not only the continuous. If you have to choose any, if you have one probability that is most popular, that is the so-called the normal distribution. Okay. Distribution. In fact, the reason why I brought this statistics basics because of to explain this normal distribution. Okay. The normal distribution is one of the continuous probability distribution. Okay. There's a reason why that is the normal distribution is so popular, is very frequently used, is because of a so-called central limit theorem. So what's the central limit theorem? So let me just write down here. According to the central limit theorem, okay, such as you have xi, this is a random variable. It's a random number, okay? Is from the I is 1 to n, large n, okay? Then this random variable is following the IID. IID means is independent and identically distributed. Okay. So independent means that is, let's say if you have a first number is a 1, second number is a 10 from this random variable, okay? Then that even though you have a number 1 first, but you have no idea what's going to be next one. So probability that number 1 appear is totally independent from the probability of the number 10 appears. Okay, that is a so-called independent. Okay, and identically distributed means what? Even though you are not able to specify the particular distribution all these numbers coming from, but still you sure that these number coming from only one particular the probability distribution. Okay, that is a so-called identically distributed. Okay. So once you have a certain, the series of a random number, and especially is independent and identically distributed with the sum distribution, probability distribution with, let me make a space here, let's write down continually, and with mean of mu and standard deviation of sigma. Okay, so still we have no idea what's the specific the probability distribution that is all these numbers coming from, but still we already know that is the standard, the mean and standard deviation. That's all. Okay, and then if you're saying that n number of this random number is greater than the 30, then this, let's say Sn is just x1 plus until the xn and divided by n, make an average, especially this small n is less than n, capital N, then this Sn, this averaging out a sum number of this random variable is following the normal distribution, with the mean is a mu and standard deviation is sigma n. Okay, sigma n square. Okay, so that's the so-called central limit theorem. Okay, So in fact, this is very powerful, okay? Very powerful theorem, okay? And also this is the reason why the normal distribution is widely used in many places, okay? Because if we satisfy this IID and also is greater than 30, okay, and also we know the mean and the sigma, then even though we have no idea, okay, about this probability distribution, in most cases it's true, okay, then we can easily, safely apply assumes this lambda number following the normal distribution, okay. I mean, just imagine that if you try to use some statistics, especially based on the probability distribution, in the real cases and in realistic cases, you are not able to specify that the particular probability distribution. Probably in most cases, you are not able to. It's almost impossible to know the exact probability distribution. Okay, but still in this, according to this central limit theorem, if you satisfy some of the requirements, these assumptions, then actually you can safely assume that those are random number following the normal distribution. That's why it's a very powerful, the theorem in statistics, and also this is a reason why we use this normal distribution very frequently in many cases. Okay. So here's that. Let me talk about some of some special the nature of this normal distribution. Again, normal distribution is one of the continuous the probability distribution. So that's why the way you describe the normal distribution is only this way. That is, let's say X follow the normal distribution with mean is a mu and sigma square. When you describe the normal distribution, any kind of normal distribution, let's say xi is here, I is from the 1, 2 until the n. Whenever you describe any kind of normal distribution, you have to always provide two informations. What is that? The mu, the mean, and sigma square. That is a variance. Okay, why? Because you might already see this before. Okay, that is, what does the normal distribution look like? That is, over the continuum line, that is, normal distribution, it look like bell shape. Is a bell shape. Okay. So under the normal distribution, okay, it can take any random number from the minus infinite to the plus infinite. Okay. Normally in the top portion of this curve is what? Mu. Okay. Is the average, the mean. Okay. And then the reason why we have to specify this mean and the variation is because the mean is provide a position of this bell shape of a normal distribution under the continuum line. Okay, so that's why you have to provide the mean. And also sigma square, this variation is indicating what? That for example, let's say if you have a very small the variation means what? This is the width of this, the normal distribution is getting the narrow. Okay, so if you have a smaller the variation, smaller sigma square, then it's look like this one. Okay, but on the other hand, if you have the higher the sigma square variation, that means what? It become the lower, the top portion is getting lower and is dispersed. So this way. So depends on the variance, sigma square, the shape of this normal distribution could be very different. Okay. So because of that, whenever you provide whenever you specify the normal distribution, you have to provide these two information at the same time. What is that? The mean and variance, the mu and sigma square. Okay. So here's that. One of the special nature of this normal distribution is, again, this is one of the continuous the probability distribution. So that's why the way you describe the particular probability under the normal distribution is, let's say, what's the probability x is just the x is between a and b using interval instead of a discrete value. Okay, and especially under the graph, that is, the way you describe this, the particular probability is this way. Let's say A is here and B is here. Then this is just indicating the area under the curve, area. That is this probability. Okay, this is the way you specify the particular probability, especially in the interval on the normal distribution. Okay, and also another, the special nature of a normal distribution is a so-called symmetric. So if you have the line across this mean, okay, and then this left side and the right side, entire left side and the right side is exactly same. So for example, once you draw this bell shape on the paper, and then you fold in center of this mean, fold this paper, center of this mean, then what happened? This line and this line are exactly match. Okay, why? Because left side and the right side in the middle of a mu are exactly same. So that's why, in fact, is drawing the normal distribution is not easy job to do. Okay, it's very hard with drawing the correctly the normal distribution. Okay, on the graph. Okay, but let me ask this: what's the probability that is this x is still coming from the normal distribution? So mu is the mean and sigma square is variance. Then what's the probability is x is between the minus infinite to the plus infinite. So this is indicating entire area under this curve on the graph of a normal distribution. It's just always, yeah, 1.0, 100%, right? Yeah, so this is just the basics of statistics. Okay, if you added up all the probability of every events, that is just 1.0. Shouldn't be less than 1.0 or greater than 1.0. It should be always exactly 1.0. Okay. Then another question is, what's the probability that x is between the mu and the x? Let me make a space here. Probability x is between the mu and plus infinite. So in fact, both are the same, right? Okay, why? Because it's a symmetric, okay? And it should be what? Yeah, half of one is 0.5, 50%, okay? So that's about the special nature of a normal distribution, okay? And then another thing is, actually there's another very similar the distribution out there. What is that? So-called the standard normal distribution. So what is a standard normal distribution? Standard normal distribution is like what? The sum of a normal distribution, okay? So this is another, the continuous, the probability distribution, okay? So this, the way you describe this standard normal distribution, okay, I mean, the way you describe the probability under the standard normal distribution is using the interval, okay? So what's the difference between the normal distribution and standard normal distribution? Is the only difference is mean and variance. So in fact, such as standard normal distribution is just a way you describe the standard normal distribution by using normal distribution is just so simply the 0 mean and 1 variance. Okay? Or you can see the 1 square, the same one. Okay, so that's the only difference. So still, if you draw the standard normal distribution under the graph, that is, it could again, just like a normal distribution, take any value between the minus infinite to the plus infinite. And in the middle is mu. Okay, so top portion of this curve is a 0. Okay, and then also this is also symmetric. Also, just like a normal distribution, the way you describe the probability is what? It's the x is following the standard normal distribution. X is the using the what? I'm sorry. The interval. Also, on the graph, this probability is described by this way. This is the area under the curve. Okay. So reason why I brought this, the standard another probability distribution, that is a standard normal distribution, because there is quite a relationship between the standard normal distribution and the normal distribution. Okay. So this is very popular, that the theorem in the statistics, that is, let's say xi coming from the, let's see, let me just delete it first to write down this again. Xi is following the normal distribution with the mean is a mu and sigma square is the variance and I is a 1, 2 until the n. Okay, then if I have this simple formula, xi minus the mu and sigma divided by sigma, that is, let's say this is gi, the new value, then actually this gi is following the standard normal distribution. There is a normal distribution, mean is 0 and the variance is 1. Okay, so in fact this process is so-called standardization. The question is why we need this process, because normal distribution is very widely used, as I said, but the thing is, one of the problem of a normal distribution is it's not easy to calculate the specific distribution on a specific probability under the normal distribution. Okay. Yeah, there is a way we can calculate the normal distribution. Okay, but problem is it's not easy to calculate. Okay. So in fact, normally when we try to get the specific probability under the normal distribution, we try to switch those the variable into from the normal distribution into the standard normal distribution by this standardization process, and then by using the standard normal distribution, we can get the probability of the normal distribution. Okay. So in order to get, okay, I have to show that how to use the so-called standard normal distribution table. Okay. But still, I think that I spent a lot of time. Okay, so let me just stop here and continue with this next time. Okay, so in the next time, I will show you how to use the standard normalization table I already posted on the Cyber Campus to get the probability under the normal distribution. Okay, so that's it for today. See you next time. Bye.